I'm Professor Sharon Robinson from the Faculty of Science, Medicine and Health. I'm in the School of Biological Sciences and the Centre for Sustainable Ecosystem Solutions here at the University of Wollongong. And I've been working on Antarctic mosses now for the last 19 years. So when we think about Antarctica, we think about this really cold, frozen continent, all icy, white, maybe a bit of blue from the sea. But when you go down there, there's all these green patches in the summer, which are where the mosses are growing. And we've been looking at how plants are able to survive in these conditions that are basically equivalent to your freezer at home. So even in the summer, at the middle of the night, it'll be down to -20. So these mosses are the only plants that are able to cope with those really freezing conditions. And we've been studying them and we're trying to find out how they're affected by various elements of climate change. So they grow really, really slowly, 0.1, 0.3 millimetres a year. So we get pieces that are about this big and they can be 500 years old. So where we're working in Antarctica at Casey Station is an area where it hasn't really got warmer over the last few decades, but the wind speeds have increased, and we think that probably there's changes to the amount of snow that accumulates each winter and the amount of water that's available for the mosses to grow. So what we've been doing is trying to work out ways that we can monitor the moss health, find out if we're covering all of the material that's there. So are we covering all the biodiversity, or are we just focusing on the stuff that's around the stations? There might be something that's a few hundred kilometres away we haven't even noticed yet. And to do that, you need to have new tools for monitoring them, because one of the problems is that the traditional ways of doing ecology are you go out and you look at the ground and you count what's there and you assess it. And that's fine if you're doing a small scale project. It's really difficult if you're trying to do it over big areas. And so we've been scaling up methodologies that we can do either with a camera tripod, so scanning across the moss and getting indications of how healthy it is, building that up to drones, so having unmanned aerial vehicles flying across the sites, and then potentially that could lead to satellite. And you might say, well, why, that's all remote stuff, what's the advantage? One thing with the trampling around in these moss beds is obviously when we're doing it, that we can't tread on the moss, because you put your boot on a piece of moss, 500 years gone. So walking around is really tricky because you have to be rock hopping around the place. Being able to do research in Antarctica is a pretty special thing. One of the great things about working in Antarctica is that you're working with your team of people. So you might be working, in our case, we're working with people who are geographers, who fly drones, people who can do spectral analysis of these signatures that are coming off the moss. We're working with chemists. So we've got this broad group of people we're working with, as well as us being biologists and ecologists. In addition to that, there's people down there working on penguins, there's people working on all sorts of marine projects, there's people doing glaciology. And so when you're down there working, you also get all this stimulation from the other researchers. You might get to help them out in the field some of the time, they help you, but even just the discussions that you get over dinner, because you're all sitting around talking about what you're doing, and you find connections between projects. So I really like the multidisciplinarity about Antarctic research.